Hello, stream number 10, working on my keyboard. Gonna do a bit of refactoring today. Where to start? Oh, I wanted to see if this actually doesn't work for a good reason. I'm not seeing this on the primary board. So if I reset the secondary board, we'll see it, I think. Yeah, the answer is no, not self-powered. But if I do the primary board, reset that guy. When it comes back up, I don't get any message. I need to figure out why that is. So that should go to the logger, which writes to the circular buffer, right? Forever have... Where do we handle the USB again? Oh, here it is. Pull USB. This one, right? So I guess what's happening is we are writing data out and it gets lost. It must be, right? It does report it quite quickly. So, I wonder if I should have it wait until we're connected. Let me try that. So, we'll say if self or matches, well, basically the same thing as is primary controller, right? But I don't want to call that because it would be misleading to me later. If the USB is configured, then service that. Let's see if that fixes the problem. Hey there, the Sweets. Using a consumer producer scheme? What's a consumer producer scheme? I'm using a ring buffer, which I made myself. It just has a block of memory and a head and a tail. And whenever we push into it, we're just advancing the head and advancing the tail and storing data into it and wrapping the tail around at the end. That's why it's a ring buffer. And then pull advances the head. Peak is reading from the head. So if I push into the host serial buffer, but I never see it come back out, that means I think it must have pulled it out and written it to the serial class, but it just got lost. Hey there, Robothic. The firmware done? It's not completely done, but I need to refactor often because I don't usually write code in one pass. I usually write pretty messy code at first, and then I have to go refactor it. If I wait to refactor it, it gets really messy and really hard to refactor. So I've been like development for, I don't know, 4 to 8 hours, then refactor a bit. And I'll refactor more or less depending on how ugly it gets. So this is looking pretty ugly, right? When we get to this level of indentation, that's a sign that we need to do some refactoring. Something like that in the heapless crate. I'll let the ring buffer. I had to be careful with my ring buffer. For example, I have to use this atomic usize from atomic polyfill because the atomics that come with Rust's core library require processor features that this guy doesn't have. The Thumb V6M architecture doesn't have the CAS style atomic instructions. They compare and swap, I think it's what that stands for. So I'd use a polyfill that does have support for this architecture. So using a crate from someone else to provide a ring buffer would be a problem unless they did the same thing. Ring buffer just means a buffer, and then you have a head and the tail, and as you push data into it, I mean, you can use whatever conventions for these names, but I think of you're adding data onto the tail, right? And then you're consuming data from the head, just like it was a queue. But if the tail gets to the end of the buffer, then it wraps around to the beginning. So you can envision it like you take a buffer and then you turn it into a circle, right? Where 0 is at the top and it goes around and then back up to 0 again. And so when you push and pull out of it, you'll see a lot of these modulo sizes because that's where it's wrapping around. That's all that a ring buffer means, is that a buffer that you kind of twist into a circle. The advantage of that is that you don't need to move data around after you consume it from the head. You just move the head pointer. The downside is that when you pull data out, you might wrap around, and so you have to reassemble from possibly 2 fragments, from the head to the end, and then from the beginning to the head. I kind of cheated here and I said, you can only read 1 fragment at a time. So if there's like 10 bytes in the ring buffer, but the first 5 are at the end, and then the second set of 5 are at the beginning, then we're going to read 5. Your head will wrap around to 0, and then you'll read 5 again. And that's another thing I need to refactor is this. This is only doing 1 byte at a time. We can be more efficient. Is it possible to create a ring buffer without unsafe? I don't think I used unsafe. I don't think any of this is unsafe. I don't think I used any unsafe. Oh, I did. Why did I use unsafe? I think I can refactor this to make it not require unsafe. I think I was just lazy here and I did from raw parts. Yeah, so that's something that I can maybe refactor, is to not require unsafe. It should be safe, right? Because we're just taking a slice out of an array that sits here. There's nothing unsafe about that. I was just lazy. I think I copied that from somewhere else in the code. The only other thing that's possibly unsafe is the implementation inside of this atomic usize or arc, which I think I did implement my own arc for the same reasons that it isn't possible to use the one built into Rust for this architecture. Yeah, I did use unsafe. Is that because this is unsafe? This might not need to be unsafe anymore. Hold on. So what happens if I remove the unsafe here? Okay, it's unsafe because I'm using what? Non-null arc inner. Is it the asref that's unsafe? Oh, it's the asref. Returns a shared reference to a value. And why did I use a non-null pointer? Oh, right, yeah. Okay, yes, that for my arc. I didn't know how to make this safe because fundamentally we have to share something that how do I say this? it's like shared ownership, right? That's what the asynchronous reference count thing is. When the references reaches 0, you destroy the object. So yeah, I did it through this box leak followed by drop in place, and all that's unsafe. Anyway, I should be able to get rid of the unsafe here. Hey there, Nui, how are you doing? So where's the memory allocated in the ring buffer? It's wherever you allocate the ring buffer. So that's one thing that's kind of interesting about Rust, is that you don't actually say where the memory is allocated. You leave it up to the creator of the instance. So if I search for all references to ring buffer, we'll go back to my keyboard thing, and right now it's on the stack. When you call new and it just returns one, that's on the stack. So if I were to see what does split do? And my arc new, what does that do? Aha. So that does a box new, so it's going to move it to the heap. So if you use my implementation of arc, then it's going to move it to the heap always. So I guess the answer to your question is, as soon as I split the buffer between reader and writer halves, I'm now using an asynchronous reference count pointed to it that moves it to the heap. So the answer is heap. Hey there, Dr. Padawan, how are you doing? It's midnight, so good night? Okay, good night, Nui. Okay, I was going to look up from parts. From raw parts? Yeah, okay. And I want core slice. I want the safe version of this. So is there a safe way to make a slice? I guess I really should look for array, right? Core array. Wait a minute. I know how to slice an array. Yeah, I don't need to do that, do I? That doesn't need to be a pointer, can't I? Okay, can I just do this? Sum buffer.mem slice it from head to head plus length. Can't return referencing local variable buffer. Oh, okay, that's why it had to be unsafe. Because we're just borrowing buffer from self. It's because buffer is behind this arc again. Yeah, that's how I want to do it, but because we had to get a local ref, one of these refs, and I can't cheat and do as ref, can I? I don't think you can use it as a reference. Yeah. It's because it's inside of a ref cell. Yep, well anyway, that's why. We're kind of cheating then with this unsafe. We're peeking inside of a ref cell. And it's only safe because nowhere else in this type are we going to access the buffer simultaneously from another thread. Yeah, so it's a thread safety thing. We're kind of shortcutting. Yeah, so if I were to make this thread safe, I can't do this because we might have another thread which is writing to the same region of the ring buffer. Theoretically, although I am with the design of the head and tail pointers, and especially this push here where we break if we were to hit the head when we move the tail, we kind of guarantee we won't modify where we're peaking. So how to truly make it safe, I'm not sure how to do that without making a copy. Very much like C++, how much memory is available? 264 kilobytes. That's how much memory we have. Well, how much writable memory? What would you say? Random access? No, that's not a good term. How much volatile memory? That's how much volatile memory we have. We have 8 megabytes of non-volatile memory, but we have to go through a little dance to write to it. Okay, I wanted to test the change I made here, right? Where we wait until the USB device is configured before we write to the host serial port. Yeah, so build that. This doesn't need to be quite so tall. And let's reprogram the board. So Control C, program. Okay. So it didn't work because I didn't see the message there. Let's reset this to make sure I see it. So on the host, we still don't see it. I mean, on the primary board, we still don't see it. All right. Make sure that this is the only place where we actually pull out of the host serial buffer. Oh, I bet this is happening. Yeah. We're writing it to the other board before USB gets enumerated. Okay, then I have to... So yeah, okay, this primary board then is coming up and at first thinking it's a secondary board, and then it's writing its log to the other board, and that board is probably like, I don't know what to do with your log statement, and just tossing it. So then it's, okay, then, well, I don't think I need that yet, but how do I make this decision early? So yeah, this is problematic, right? So anything that calls this might get the wrong answer at first. Okay, that shouldn't have to worry about that. Why are we making it green there? I don't think I need to do this, actually. I don't think this is needed. Let me remove it. By volatile, you mean ROM? Volatile means you can change it. No, volatile means that it goes away if you take power away. Yeah, erased on system shutdown, exactly. So the other property usually of volatile memory is it's very fast to access it, and you can access it in very small widths. So like you could read or write a single byte, whereas like flash memory, non-volatile memory, it takes more work for the CPU to access it for writing usually, and for reading sometimes. Although for this flash, it's execute in place and it's fast, so we can read flash fast, but to write it we have to access 256 blocks at least, I think. Okay, I don't really care if this blinks at the wrong speed at first. Yeah, that's fine. Wait, was that in two places? No, this is the problematic one. That's fine. Yeah, so this is the problematic one. I don't know. What if I make it so that, I know what I'll do. I'll make it so that it has to receive a message from the primary board first before it will send its log messages back over. So we'll say something like, if self is secondary controller. No, that's not what I want. I need some other word, some other name here, meaning that we received a message from the primary. So I need, the long name would be received greeting from primary. But that's too long. Something shorter than that. Oh, well, that's what it's going to be until I think of a shorter name. Make that a Boolean. Okay, and then that means we need to send a greeting, right? False. Okay. Let me see if I remember how to do this. Why do I say if connected to USB? Oh, that's this. Okay. Would I be able to use ARM Cortex-0 with it? You mean ARM Cortex-M0? That's what I have. What's the question? I don't quite get that. Would you be able to use ARM Cortex-0 with it? If we receive data from the peer, we're going to go into this state. Actually, I don't even really need to send a whole greeting, do I? But yeah, maybe under this process serial input we can do it. And in this next, right? I have an idea. I'm using this program command here. What if I extend that to include like a greeting as well? So we'll call this ena. Yeah, we'll call this. Make an enum called peer command, or just command. It's kind of too generic, but that's okay. And then I can have a greeting. Okay, and then wherever we use program command, we can substitute command. like that. And that's just a command. That's just a command. And that's just a command. Okay. This is just handle commands now. This is just commands. Here I'm going to want to do a switch, or a match. I almost wrote switch as in C++. Oops. Build match arms. So the program one goes here. And here we got command. And we'll fill in this in a minute. Okay. Commands. Okay. We're not using greeting yet. Correct. Okay, so program becomes command. And that gets set down here when we receive the entire program, right? Yeah, right here. Okay. Let me see what is called in poll USB. Okay, I need to rename it there. Commands. And process serial inputs. Rename it there. Commands. Okay, so I can add that greeting message now, right? So we'll handle the receive first. Actually, where we just were was correct, right? No, it's in this next. Here it is. I want to say here, else if. And then a bracket. I mean, I guess I can say greetings. I'll probably replace this eventually with binary. So we're going to stay in normal, but we're going to add a command, right? Command equals some command greeting. Okay, so if we receive this string on the serial port, we interpret that as a greeting, as a command, a greeting command. So then where I had that to do, here, this is where we're handling it. We handle a greeting command by simply saying self.received_greeting equals true. And let me go rename that now. I think we could just make this received greeting. Okay. Perfect. So then I only want to send my log over the serial port if we received a greeting. This is exactly what I want. Oh, we have some other problems here. What is this? Oh, shoot. This can't modify self, can it? Okay, I really need to turn this into a method of keyboard then. No problem, we'll do that. Where to put it? I'll just put it here for now. Handle commands, I guess. And we need to have mutable reference to self. Okay, now we can modify self. Okay, programmer. Did I not make that part of self? Is there a reason I didn't? Oh, right, there was a good reason. Shoot, I need to... Okay, that's going to be a problem. How about we optionally return a programmer? Let mute programmer equals none. Here, if we have one, set it. And then we're going to return it at the end. Cool. So then down here, we don't need to set up the handler. We just need to call it. Self.handle commands, and we'll say programmer equals. Although it's not going to like that, is it? Oh, I can say if let some programmer equals. New programmer. I already don't like this, but that's okay. Thinking I maybe should just make it an option thing, an option within self. Okay, so that is substituted for that. It's like I'm not doing refactoring, but doing the inverse of refactoring. But this is actually fixing a bug, right? So now we're going to handle the greeting command by setting that flag to true, and I want to test that flag when we are processing. Is it poll? Here it is. Already did that part. Okay. It's not and we are received our secondary, and we received a greeting on the serial port. Try to write data to the pure serial port. Okay, now I need to actually send one, and let's have it send one as soon as we figure out that we're connected to the host. So we only want to send it once, right? What happens if I unplug the secondary board and then plug it back in again? Am I going to care? I'm not going to care about that right now. We'll just do it once only. We'll make it sent greeting. I already don't like this name greeting, but that's okay. Okay, it'll be down here, I guess in our run function, in our main event loop here. Poll USB. I mean, I guess we could do it there. Okay, I know what I'm going to do. I'm going to move that to there, and we'll say, perform, oh, if USB is configured, perform work. I really should do this here, but I should move it elsewhere. Yeah, this has nothing to do with polling USB, so I'm going to undo what I'm doing. But I am going to copy this line, because I want to do that outside of poll USB. In the main loop, event loop somewhere. Where to do it? I think this is a bad place to put all this code. Should it just go after this wait? This is only just detecting we should do a blink. It doesn't actually wait. Do it here. Actually, this if connected to USB really belongs here now. If connected to USB, send a greeting to the secondary board. If we haven't yet. Hey there, Metal Storm. How are you doing? The game is on hold because I'm technically not allowed to do open source, especially games right now with the job I have. So this is just a side hobby project because I kind of got into making my own keyboard where I have to learn a lot of more advanced electronics. And I like the idea that my keyboard that I use for everything on the computer could be running my own code in the firmware. That just sounded pretty cool to me. If not self dot sent greeting, then we just send it. How do I do that? I think I just push it in, right? So self dot peer rx buffer writer. No. I don't have the peer tx buffer writer available. How do I write to the peer then? Is it just peer serial? Write. I can do write format? Cool. Let's just write format. Greetings. There we go. It's probably going to tell me I can combine those two ifs. So let's let it do that. Okay, I guess I can't do a write format. Or if I'd done this before. Read raw, write raw. Okay. This is misnamed, isn't it? This is misnamed. I need to fix that. Because it's not the host if it's no, wait a minute, it is the host. Okay. It may or may not be renamed misnamed, but I'll have to address that later. Where did I do this code where I actually wrote? Is it in Programmer? Oh, I did it by doing it to bytes and okay. Yeah, and ended up doing the write raw. Okay, so write raw is what I want. Write raw. So just turn it into a B string. There's a result. Do I care? Oh, shoot. That's a problem. We might not be able to write it all. It might not fit in our FIFO. Oh, bummer. Okay. Need to go back to sort of the genesis of this, where we made this in the first place. Here. Oh, I don't have a ring buffer for transmit. I used to have one, and it says so here, ring buffers, but I don't anymore. Because I'm using the other one inside the programmer for that. Oh, I'm not using ring buffer at all. I'm using this forwarding program thing. This prefix. Okay. Yep, I have some work to do here. The game is going to be open source. Well, it sort of was. Parts of it were. Parts of it were open source. All the stuff I started doing when I first started the project was open source, and then the game itself was not, but there are elements of open source in it, so I couldn't maintain that anymore. The job does restrict me from doing it open source. Yes, it does. And they also don't want me to, in general, to be working on games or apps. So, yeah. That's okay. I have other things I'd like to do. This is turning into a kind of a major change. If I were to make another ring buffer, I don't think this needs to be that size. Let's make it smaller. Because the host serial ring buffer is that size anyway. Yeah, okay, so I'll put it back. TX and RX. Yeah, that's fine. And we'll just make 2 of them now. Okay, and then need to save it here. Not using it yet, correct. That got added by mistake. Okay. So yeah, instead of writing raw directly, we're going to push. So self.peer transmit. Wait, what? How come it's not auto-completing this for me? I don't know, but this is what I want. The writer. Push. There we go. We push it into the circular buffer. And then we're going to record the fact that we sent it. Now I got to change the peer where we write to the peer serial so that it actually processes the ring buffer instead. Yes, so this part needs to be copied out, like, let's put it after. So this is, if we have any data to send to the peer, try sending it now. Try sending some now. So this is we peer TX. How come it's just not auto-completing right now? My memory's so bad. It's the reader here. Peer TX reader peak. We would pull from there. Okay. This is for forwarding log messages, so this is misnamed, right? Right, if we're configured on the USB, we write to the USB with it, but if we're not configured for USB, or if we've received a greeting, then we are sending it to the peer instead. So really I should just get rid of this, and this should be something we do from the logger itself. Or I guess I guess what I can do is write it to the peer TX buffer writer here. That would make more sense, I think. Push. It doesn't return anything. So we'll just say consumes everything. Yeah. If we have data in the host serial buffer, and we receive a greeting on the serial port, transfer the data to the peer. That's what it really should be. Language protocol bug. Could you contribute to Rust language protocol? I would have to get permission to work on an open source project because that's what Rust is. Okay. Hopefully I didn't screw up too many things here. Let me, I was going to say, let me review what my changes were, but hold on. We're polling the peer serial port, right? If we read some of it, put it into our ring buffer for receiving. So we'll pull it out later, down here, inside of our main idle loop. If USB is configured, basically, then we're just basically forwarding whatever they tell us, and just assuming it's a diagnostic message. Otherwise, we're not configured for USB. We receive something from a peer, then we're having it processed through the serial input. So it could be a program command, it could be a greeting command, or it could be receiving a program. I mean, that makes sense. Right, and then we added this where if we haven't set a greeting and we're configured, I should just do this is primary controller. We're the primary controller if our USB becomes connected, right? So if we're the primary controller and we haven't set a greeting, send one to the peer through the ring buffer. And then here's, yeah, we just looked at this, right? Okay. I feel okay with this. Let's see if it works. If it doesn't work, then we'll revert. Or fix it, right? If it works, it would be nice. First try. Here we go. We're reprogramming. It's not blinking. Oh, but we did... Oh, everything's on peer? Ooh. And it crashed. Okay. That's bad. Reset it. Did it crash again? Before we could even connect to it? I'm waiting for the... Sometimes there's a delay, a host delay, to connect to it. I'm patient. Go ahead and connect. I think I see the problem. I peaked, but I didn't pull it all the way out, all the way out. I think it's just stuck. Okay, then I think I know where the problem is. It would just be better for me to go find where it would be, right? It would be pull here serial. Yeah, see, I got it up. I didn't pull it out completely. That would be push and then pull out of this one. Data dot length. There we go. I need to do that. Otherwise, it's going to keep processing the same thing over and over again. So then build this again. But I think I'm going to have to flash it the old-fashioned way. So I'll do that. I hold down the bootloader button and then reset it. And it should come up in bootloader mode. And then just do a flash there. Not working. Reset it. It's crashing somewhere else now, I think. Okay, what did I break? Broke something. Who's out here saying coding is like doing math? I think coding is more like solving a puzzle than doing math. And a lot of times the puzzles are of your own making. Coding is more like making something, and then like making a machine and having the machine not work at first and then figuring out what you did wrong and then fixing that problem until you get it to work. That's more like what coding is. They say it's the same as solving a math problem. I don't think so, but maybe it's subjective. I never really thought of it as math. Okay, what did I change here? Oh, right, I just encapsulated that. Please don't put links in chat without asking. And why are you sending me a link to someone's YouTube channel? It's probably not that change. Probably not any of this stuff, right? Sent that, no. It could be this. Let me look at this carefully. If we've received a greeting and we have something to push it into the ring buffer, because it talks about how being good at high level math really helps with coding. Oh, okay, but I didn't ask to watch a YouTube channel. My opinion and advice, I'm working right now, sorry. I'd love to chat about anything, but this isn't an Ask Me Anything stream right now. I'm trying to get this work done. Like I can answer questions, but I'm not going to have the time to go watch videos, and also it's kind of sketchy on Twitch to ask someone who's doing live coding to go watch a video from a channel they don't know. So At least I think so. If we have any data to send up here, try to send them something. So write the serial port. I'd be more willing to check that stuff out if, like, I got this working and then I was kind of going to more of a just chatting stream and I'll never get rickrolled. Yeah, so you just have to wait until I successfully get something working and I'm in a good mood and I'm like, okay, let's just chat for a while, and then maybe you could send me the link and then you successfully rickroll me. You'll have to wait for that opportunity, I think. If we had data in the serial port, so that's if we're configured. So we used to just do it always, right? Now I put it around that. I wonder if that's the problem. I could try taking that out and see if that helps. I'm making it crash somehow, though. That's the problem. Commands push. I made too many changes. It shouldn't matter that I set the LED to green. That was dead code. I mean, that was old code anyway. Okay, nothing wrong there. That shouldn't be a problem. This will only do it once, and it'll put it into a ring buffer. I don't see a problem with that. Can't find any easy open source CPU firmware to analyze for learning purposes. Anyone got suggestions? What about the Pinchy keyboard? You want to check that out? Oh, CPP. Don't know about that. I've been searching for Rust firmware. C++ firmware, though, I haven't been searching for. I mean, it shouldn't be too hard to find. If it's like for this kind of stuff that I'm doing with keyboards, maybe start with Reddit. There's a couple subreddits about custom firmware, right? Or you could look at QMK, for example. There we go. That's written in C++. That's written in C. Is that close enough? QMK. This one. Here we go. Open source keyboard firmware. It's C, not C++, though. But that's very, very popular. It's what most people use, I think, when they're making custom keyboards. Open source keyboards. I'm struggling to see where my bug could be. Yeah, it's dead. Shoot. It's dead after the initial report, right? Ba-da. Ba-da. Yeah, it's not even booting up long enough to be recognized. Okay. What did I do? It has something to do with, see, the other ones, if I unplug this one, and plug this one in. Ba-da. 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 Oh, I gotta unplug my bus. Confuse my bus again. Plug everything back in. Turn the camera off and on. Okay. So, flash. Make sure they both have the same program in there. Okay, now it's running. Okay, that's weird. I don't understand that at all. Why would it mess up just because the other one doesn't have updated firmware? Okay, well, anyway, I don't know what situation I got into where it crashes. I'd love to debug that, but I'm not sure how to reproduce that. Anyway, I fixed this, so now it waits until the USB is configured and then it prints that out. And now we're getting the answer for both boards. Know that they're not self-powered. So I can remove that because the question has been answered. They're not self-powered. I think we already knew that, right? So let me build and let me make sure that the programmer still works. So that's Control C and program. Still works. Okay. And the LED colors were better this time, right? It's white when it's receiving a program, and then it turns... Okay, it shouldn't be blinking now. It should be staying purple. Okay, and then we have the other problem where the peer didn't get all the program this time. So reset it. Try again. Yeah, I think the COM port speed is too high still. Oh, wait, I know the problem actually. This guy doesn't know he's a secondary board because he hasn't got the receipt. Oh no, he does know. That received greeting, right? What did I have it do? What does that control? Oh, that's just for the log messages, right? So that shouldn't affect programming. Let me reduce the serial port speed. I think it's just too fast right now. I think I'm just going to go back to where I had it before. Standard configuration 115.2. Let me go look at the Git history. Koba 789 Rusty keys? Haven't heard of that one. Yes, I want this string here. Common configs. Thank you, Git history. You rock. Go back to that. Build that. Question is, will I be able to program it? I don't know. Make sure that the... I mean, it could be a loose wire too. No, I just don't think it's actually programming it right now. So, I'll just flip this around. Now they should both be on that same baud rate. So the program should work now, right? No. The UART communication's not quite working. Reset that guy. Was that it? That has to be reset again after that guy? Because the greeting's only sent once? I think that was actually it. Ba-da. 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 It's testing back and forth. Okay, it's working. I don't really mind that the programming speed takes a while. As long as it's reliable. I think I'm going to keep it like this. I'm not going to try to speed it up and risk things, so... Okay, so I think the problem is if I reset the slave device, this doesn't work anymore, right? Yeah, so it's not in the correct state to be programming for some reason. Oh no, it is. It's just not forwarding log messages. Oh, because it hasn't received the greeting. Okay. So yeah, he knows he's a secondary device, but if I reset him, he doesn't know anymore. All he knows is that he's not connected to USB. So... it makes me think that I should send the greetings, like, occasionally. Like, every once in a while, when nothing else is being sent. There's no harm in that, right? Just sending it over and over again. Like, it doesn't need to be that often. It could just be every second. Like, once a second, just send the greeting message. Let's do that. Okay, so keyboard sent greeting, right? Let's get rid of sent greeting. Hi, what target are you compiling to? I am targeting to, well, this board here is the KB2040. The device needs assurance, affirmation, and love, apparently. Yes, of course it does. You need to stroke its buttons once in a while. Yeah, so the other link, I'll type it for you. It's made by Raspberry Pi. So, if I show you a close-up. I'm not very good at raising this up to the camera. It's hard for me to stay in frame. That's the microcontroller here, that bigger chip underneath the red and black wire, and then that little one off to the side is where our program is stored in a flash memory chip. I don't know why I have such trouble holding this up to the camera. But it's a really teeny tiny board. It's kind of nice. It's the same form factor as a couple other controller boards that custom keyboards are on. GD32V, I haven't heard of that one. So I have this Korn keyboard, right? And it's got this Elite C microcontroller. So it's the same form factor as that KB2040. So that's why I picked this board. Okay, sent greeting, we don't need that anymore. What I want is to send it periodically, so it's going to be a timer, I think. So let's make a timer. Set up a timer to be used to send a greeting message to the secondary controller. So we'll call this the greeting timer. And I might as well just tell it to count down, right?
I know. She thought someone evil was coming.
Start. Autocomplete, please. Really? I don't know why I had to like pull that pop down up with the dot. Anyway, so the count would be so just make it a constant greeting interval. Milliseconds? We gotta be consistent, right? If we say milliseconds, it's gotta be milliseconds. Oh, thank you. Look, chat. Mrs. Reimer gave me dots. Yummy dots. Alright, so... Here. Const that. I don't know, isn't she nice? I got dots. So this is just because 1,000, right? Okay, so we're gonna check it out here, right? So this would be if for the primary controller and the greeting timer dot wait is okay. It's bizarre, but wait doesn't actually wait. It just polls, non-blockingly waits, and it's okay if it is if the timer is expired or rolled over at least once, right? So I'll just do that. Okay, and reprogram. Oh shoot, it's not going to reprogram the secondary device, is it? But it will if I do it one more time. Why is it flashing red? Is it receiving the greeting over and over again? Odd that. I should look at the code to see where do we set the color to red. What state is he in? Crashed? Is he crashed? No. Let's plug him in here and see what happens. I think it's dead. Yeah, it died. It didn't get programmed correctly. See, it's flashing red for some reason. Why would it be doing that? It's every time it's receiving a greeting, it's turning red for some reason. Program. Oh, I know why. Because we're sending the greeting while programming, so it's going to be a completely trashed build. Yeah, okay. We can't send the greeting while we're programming. That's bad, bad news. We're corrupting the flash when we do that. Yeah, okay, so let's just unplug it for now so we don't corrupt it. And fix that. So, yeah, see this eatings. Shouldn't be doing that. This should be for the primary controller and I can't type this. Programmer. Let's make a method called like is active. So programmer is over here. Pub function is active. Borrow from self. Bool. Not boon, bool. Match. Well, it just matches, right? Self. Programmer. Inactive. and invert that logic. That's it, right? Okay, so only if it's... Why don't I just turn that around? Is inactive. That makes more sense to me, because then I don't need to invert this. It's just if it matches the inactive state, right? Matches the inactive state, then don't send a greeting. Build that guy.
Okay.
Program. Yeah, it's not actually powered, so it's like hearing echoes of its greeting. Now we can plug it in. Let's make sure it doesn't send the greeting while it's programming. Okay, cool, fixed it. Now I don't want it to green. Okay, there's two things. This shouldn't blink green while it's programming, and this shouldn't be flashing red like it is. Kind of hard to see that, right? Because the camera, just trust me, it's flashing green, but then occasionally red, and I need to fix that. Oh, let's catch up with chat. It's like WebSocket's ping if it's live for another board. It says it's the RP 2040 chip. Yes. Got pork rinds today. Is that better than dots? Hey, the tin spin. So the undocumented address to be able to replace firmware on the fly. What was it again? The undocumented address. I'm trying to remember what that refers to. Do you mean the boot ROM functions? Those are documented. So are you talking about the boot ROM functions? So there are, there's the lookup helper at address 18 and the boot ROM function table at 14. And then you just have to know the calling convention for the ROM table lookup function here. It takes a pointer to a 2-byte slice, really, and the U32, and it returns you another function. So I transmute the tag. Actually, how does this work? Right, there was like the 0 extending. Yeah, you have to take that 16-bit pointer and extend it to 32 bits. Oh, right, the tag, which is 2 bytes, gets extended to 32 bits for some reason. Yeah. I hope that's what you're looking for. They're documented, though, in the datasheet. How to look stuff up from the boot ROM. I had to do it myself manually because we need to look it up before we go into this critical section. Okay, why is my LED blinking red occasionally? NeoPixel. Actually, I guess I can just search for brightness. Here, right? Oh, this isn't... Okay, it's old code then, yeah. This should just be command, right? And then we don't want to do that. There's no reason to do this. It's just old code. Yeah, that was it. Old code. So you're writing your own boot ROM? No. But the boot ROM's the only thing we're not reprogramming. I'm only reprogramming from the second stage bootloader on. So essentially what you build when you use this Cortex M and MRT is you're building something that is placed at the beginning of Flash, the part that you can reprogram by erasing it and programming again, and that starts with the second stage bootloader. So the first stage bootloader is in the boot ROM, and then also in the boot ROM are those functions, including the functions to erase and program Flash. So it's like convenience functions placed there, and those are truly ROM. We can't change them. We can only change what's in Flash. Again, starting with second stage bootloader and the rest of our program. Second stage bootloader, this boot2 comes from one of these crates. I can't remember which one. So definitely not changing the ROM, and we're not providing all of the program. There's some first stage bootloader and some helper functions in the boot ROM, and that's to access those. I'm going through this dance of going through a ROM table lookup, right? That's to find those convenience functions in the boot ROM. I believe the boot ROM is at address 0, which is why Flash starts at address 1 and then all zeros. So that upper bit is set if you go to the Flash. If it's not set, you'll go to boot ROM. If this other bit is set, you'll go to RAM. I believe that's the top level memory map. Excuse me. Okay, I built it, right? When in doubt, build again. And program. Eventually I want to make this into a GUI and not a command line tool. Okay, the intermittent red is gone. Now I just need to not have it not blink while it's programming. So that's a similar fix, right? That's down in where we do the blinking is where? Here? Here. Yeah, so if we're in the normal state and we're not programming, so and programmer is inactive. How do I combine that into this? Something like that, but it's going to tell me I can. Oh, I thought it would tell me how to combine those two. I can improve on that a little bit. I'll do it in a minute, though. I'll build this. Like, I think I'm back into a stable state, right? Where everything is as I expect it. Programming works. I should test resetting the peer after resetting the secondary after the primary is gone. Oh wait, that didn't turn red. That code I deleted, actually I think I needed it. I needed it partially. I needed it for setting it to red before we reprogram, I think. Anyway, this should be able to reset, and then programming should actually work again. Okay, except for it was white when it should have been purple. But that's the code I deleted. Okay, then I did need that code that I deleted. But it needs to be in a different spot, so hold on. Let me look at the diffs and try to get it back. And I realize I've gone a bit far without checking code in. It's just because I felt like I was so close to being done with this refactoring step. Let me find it. Actually, was it in here? It was right here. Yeah, okay. I need that. But I need to move it somewhere else. So copy it from here. It's when we get a program command, right? Yeah. So it's down here. Actually, I guess I can do it right here, because it's in self. I can just do it right here. Program. Set the neopixel to purple, right? No, I shouldn't do it here. I should not do it here. I should do it where we actually Actually, no, that's a... Hold on. I keep going back and forth. I'm vacillating. That actually probably is an okay place. Actually, yeah, we'll put it here. That's where it should go. All right, so then build... program again. Is there a chat command for what I'm working on? Yeah, it's called project. Hey, MCS Mike. I also have more information with notes. Making my own keyboard. If you're interested in the controller, that's got its own command. KB2040, which is using the Raspberry Pi. Okay, I'm gonna program and I'm gonna watch the colors to make sure that they're what I expect. Okay, it's white, and then purple, and then that becomes white. They should both go to red. And they should both reset and go blinky again. Nice. Okay. I'm happy. I got that connection delay, but I'm okay with that. 715209, how are you today? I'm doing some refactoring of my keyboard firmware. Sure, that could be its own commit. Why not? Literally adding programmer is inactive. Next. All right, what else did we change? Right, we put the UART back to slow again, so let's stage that. The stage keyboard shortcut's too complicated. Too complicated for me. That's a little complicated. Can I just stage one line here? Okay, I'm not gonna bother. You know, I'm tired. Let's just stage the whole thing. I call it one big refactoring step. Have I missed your message? Maybe because it's in red. Let's see, what did you see? Oh, there was... It's been a long time. How's it going? How are you streaming again? So I've also started using Rust, switched to it. I've been using Rust now for a couple of years. But I just haven't been streaming very much. So I streamed, I've been a code twice using in Rust. I started switching my game over to Rust before I got my job, and what else did I do in Rust? Oh, I made an introduction to Rust series on YouTube, and I'm doing my keyboard firmware in Rust. So I'm really into Rust for my spare time hobby code. But I've seen you, Gelmega, I've seen you in Primogen's channel, so... Sorry I missed your messages. I think I missed your messages because they're the same color as me and my bot in my chat. So I think I glance over and I think that they're just my own messages, which I don't need to read, right? So this is refactoring and fixing LED state. Okay, what were the major... So sorry, Gelmega. Major thing... Okay, yeah, that was one step. So slow UART back down to 115/200 baud because I've been seeing data loss during program transmission. Next diff. That's part of the baud rate change. Oh, right. So the peer I reduced the amount of memory that the peer serial port ring buffer uses. So reduce, well, shrink peer serial port ring buffer size down from 8192 to 20048 bytes. Since we didn't really need as much. Since we really didn't need so many bytes to begin with. Next. Right, we're sending the greeting every second now. So use, whoops. Have primary controller send the secondary a greeting every second. So that the secondary knows it can send its log. Well, knows its role, really. Knows its role and can send its log to the primary. Also currently wrapping some containers to make them work with your allocation system. Most allocators seem very ad hoc. It does seem a little bit of work needed, right? There's a problem I was seeing. I have to use the nightly build of Rust because of this feature is not stabilized yet, but you absolutely need it if you use the alloc crate and you provide your own allocator, which I'm doing in heap. Global allocator. So if you do your own allocator, you have to implement this error handler, and that error handler requires that you enable this feature, and that is only available on the nightly build, which tells me they still have some work that they need to do in Rust itself. But that's okay. It's not too bad. Okay, back to diffs. There's the greeting message. Okay, I should say something about make room for there being more commands than just programming. That are triggered by receiving data over the serial port. Sort of open for extension now, which I thought about last night and I just didn't feel like doing then. Okay, yeah. Route all data to be sent to the peer through a ring buffer. That's the baud rate stuff. There's a new ring buffer. Yeah, we already talked about this part. Yeah, this is the new ring buffer. Okay. I think I added this because I figured we only want to try to write to the host serial port if the USB is configured. Oh, right. This fixes a bug. Fix bug where messages to be sent to the host might be lost. If the ring buffer holding them is drained before the USB is actually configured. Yeah, that was a bug. So I let this diff get a little too big, didn't I? I have some new Rust learner here. What's the difference between macro rules and defining function? A macro is something that is evaluated at compile time, and a function may be evaluated at compile time, but usually it's evaluated at runtime. So you also have the ability with macro rules to make a little bit more flexible syntax, whereas a function, it's a very rigid syntax. So two things with macro rules: it's evaluated at compile time always, and you can adjust the syntax to suit your needs. So you can do things that kind of stretch the existing Rust syntax and extend it, right? Defining a function is more of like, you need it to run at runtime and not compile time, or if it's a constant function, it'll run at compile time, but you don't need any of the extra syntax that you might get from making a macro. That's basically it. So I get kind of confused by the macro rule syntax, so I generally tend to avoid it, and I'll just define functions. Even if I want them to be a compile time, I'll just make it a const function. Seems like they looked at C++, saw how bad its initial allocator system to connect to containers and decided to copy it. I actually think that probably what happened is there was just disagreement in the community of Rust developers, developers actually making the Rust language itself, and they just haven't resolved all the differences yet. That's fine. It just takes time. Yeah, think of macro rules as a way to expand, just like macro in the preprocessor for C++, it expands something at compile time to kind of emit more code for the compiler to absorb. All right, so let's see. What else did I do? Okay, I fixed the bug where we turn the LED a different color, right, when we get a command. So fix bug where we changed the LED color when any command was what's the word? Emitted? Generated? Rather than only changing it if that command was related to programming. Okay, also we fix bug where we continue to blink the LED while programming. Anything else? That's this continuing to blink while it's, no, what is this? Oh, this is dead code. Yeah. So, delete dead code, which would set LE. I can't type this very well. Where exactly was this setting it to red? It was in the normal state? No, it was setting it to green. For some reason, I was... Oh, setting it to green if it's a secondary controller. Fix delete dead code which would set the LED to green if the controller was the secondary. What else? Too many changes in this commit. Okay, handling. Okay, make extract. Handle commands. Function. And that's where that code ended up. That sets the LED when we when we accept a program command. I think I already mentioned the greeting message. And I already talked about fixing that bug. Okay. Move that around. Yeah, we extracted that function. It's sending the greeting. I think that was it. All right. That's enough things in a commit. Too many things. Mega commit. So we're in a good working state, all bugs fixed. Time to actually start to do some cleanup. So let me go from the top. I have a lot of uses. Hopefully that goes down by the end when I put these into other modules, right? We could put a comment here. Sizes of various ring buffers in bytes. Different blink. And ping intervals. All right. I think I want to take this entire serial input state and move it out to its own module. I think we'll call it serial input. So new module called serial input.rs, which from main will declare. Okay, and then everything related to serial input state moves there, including commands. It's all this stuff. Right? All of this moves out to serial input. Done. Okay, so we're going to need to import back, and we're going to import info, import min, sector size, flash staging offset. Although this doesn't really belong here. You know what? This ought to be a command, right? Yeah, we have this command structure now. This ought to be a command to go. Oh wait a minute, no. It can't be a command because we actually have to finish doing that before we update our state. Yeah. Okay. I have no choice. I have to do that there. Yeah. Oh well. Unless I extract that out as another function and then we somehow give that function. Or make that function global or something? I guess it could be. It could just be part of the crate. Like program sector or something. Well, it already is flash program sector. What's different about it? The info message? I could move that into flash program sector. Anyway, that's done. So then we don't need this. Fix up this stuff, right? So import serial input state. Oh, because it's not public anymore. All of this stuff will need to be public. Pub. How come it's not working? That was weird. Just try again. Alt click on all those things. Oh, because the alt... Okay. My keyboard is fighting me. I need to release the alt key, basically, or else it's going to continue. Okay, so release the alt key, type pub. There we go. Took me long enough. Next has to be public. All right. Hello, buffer. Don't overflow now. How are you doing, buffer? 0xAA55. AA55 is alternating ones and zeros pattern common in embedded programming as well as hardware design. So we can import that now. Oh, did I fix up? Yeah, sometimes these spaces get added in my uses. I don't like those. Release the alt key. So this is what I like. Removing these unnecessary uses from keyboard so that it's smaller. Command comes from serial input. All our commands come from the serial port, basically. And is that because it's not public? Yeah. So I need to mark that public. All right. Okay, I'm going to do smaller commits now. I'm going to build and then program. And we have to program twice to make sure the programmer itself isn't destroyed. Right? So program once. And program twice. So whenever I'm programming both of these boards simultaneously. So what you're seeing here is very quickly, within a second and a half, we've already sent the entire program over this USB port from the host to this first chip and written it into the staging area in Flash. Then what you're seeing in the second section is we're forwarding the program to the secondary controller, which is that's what these peer is. So this is a log message from the peer, this guy in the bottom, whereas this message is from the primary, the first one, and it's going over this wire, which is much slower than the USB port, so it takes a while. And we're also waiting a bit between programs because we can't actually transmit while this guy is busy programming, or else his FIFO gets overflowed, and so it's a bit of a dance. At the very end, when this one has both received all of the program and forwarded onto this guy, they both simultaneously reprogram themselves. It's a boot signature. How far am I into the implementation? I gotten several things done, 715.209. Should update that areas that need work. We got key sensing done early. Figured out how to write to the flash. I figured out how to design the PCB. I did a little bit of work on that yesterday. I don't have it on here, but I should put, like, under learning how to flash, we have a program secondary controller from first, or from primary. We did that. This TRR link between controllers, I think we can call it done. No, we can't call it done because all we can do with it is program. We can't actually forward key state yet. So maybe I'll just replace this and say forward or exchange key state between controllers over a TRS, which is the UART right now. Another thing I was thinking about is maybe we don't use UART over the TRS. We could use a different protocol like SPI, or what's the other one? I2C. A couple of buses that get used there. And we haven't done I haven't done anything with LED chaining or addressing. But this, I've been mostly focusing on these two, writing to flash and programming the secondary from the primary, just because it's more convenient going forward to get that figured out. So it'll be the physical keyboard layout, staggered column. I think I'll probably shoot for something that I'm familiar with, which is this corn, but it's going to be kind of customized. I'm thinking about adding the sixth column back on the end here, and I don't know. We'll just see where we get. I haven't decided if I'm going to go low profile or not. It'll probably be ortholinear. Is that what they call it? The columnar? Just like this corn is, just because I'm getting used to it. I should show you what I have so far. I did this a little bit yesterday. Show you the PCB I have so far. It's too bad that there's no shortcut from this layer. So this is the PCB I have so far. Just taking what I have here and adding a few more keys, and it'll be basically replacing these solderless breadboards, just to prove some things out. Like, I want to make sure that I can socket the controller so that if I make a mistake elsewhere on the PCB, that I can just pop the controller off and put it on another board. I want to make sure I get make sure I don't have any mistakes in the PCB design before I make the full on set of keyboards. So Like, I decided to make this intermediate step because it's something, if I make the board small enough, it's really cheap to make a prototype, and it gives me more confidence that I'm not doing really horrible mistakes designing the PCB. No short circuits, VCC to ground or anything like that. So this is the state of the keyboard in real life, and then over here is the state in design land, and then come back in a month and this will probably be the real world, and then the design land will be the more complete keyboard. I like to do little steps, you know. I'm not one to like try to go to the full-size keyboard in one giant leap. You waiting for a kinesis advantage? Neat. Okay. Yeah, okay, I forgot to make this commit. Git commit, stage all of that. Okay, so in this commit, we extracted out serial input state to its own module. All right, next. I'm whittling away at the size of this keyboard.rs because it's at 619 lines. It's still kind of long. Okay, nothing I can do about new, right? That's just resource construction. So let's button that up. Polls peer serial. It's processing ring buffers now, which is fine, right? This is filling the receive ring buffer. This is forwarding for the secondary controller. And this is sending things to the peer. Okay. You missed the drop release because drops screwed up, opened it too early, and the mail to notify people came in a couple hours after it was sold out. Oh no! You had to race a sellout? That sucks. Okay, this is nice and small again. Full USB is good. Process serial input. Okay, here's another opportunity, right? This stuff about the LEDs. I don't think this is the right place to do it. I think this is unnecessarily... Oh, wait a minute. No, I was going to say this is unnecessarily writing to the NeoPixel, but it's only doing it when it receives input off of the serial port, right? I don't suppose these can be combined? No, even though we don't say the type, they're different types, so they have to be separate. And the Moonlander, huh? It's kind of cool how there are so many different keyboards out there. Everyone has their own different preferences. I'm thinking about making this one a separate method. Let's just do it. So extract into function, and we're going to call this function reflect serial input state on LEDs, on LED. It doesn't need to be immutable, does it? Oh, it writes to the NeoPixel. Wait. Why can't it be mutable? Oh, because serial inputs... Wait, what? Mutable borrow occurs there. Oh, the input is a slice. Yeah, okay. I can move this. That would be better anyway. There. This shouldn't be a problem. Why? Why do I have this in an else anyway? That shouldn't be in an else. Okay, I think the solution to this is not to have this input thing persist, but to just call self received as slice. And consumed is the variable that we keep around, right? Or offset. Let's call it offset. Type of this. Yeah, the problem is we're holding on to a mutable reference of part of self, so we really can't do that, which is a bummer. Well, can't I move this out? There's no reason it has to be inside. Actually, it can be all the way at the end. Update the state of the LED based on our final serial input state. And that's already mentioned here, right? Update the state of our LED. There we go. Fixed. Hey there, Master Agent Miyazaki. How long have I been going? Almost 2 hours. So I'm just trying to clean up my code here. My code gets really messy. I'm sorry, chat. I'm trying my best to clean it up, though. Handle commands. I mean, this can just be its own method, right? What happens if I do extract met function? Yeah, that's what I was afraid of. It makes it mutable. It would really be better to just say programmer equals. Remove that. Make it just return this. Take that out. And then just say that. Or even better would be to just move this here. This doesn't return anything at all now. Oh, I didn't even need the command. Okay, then what to call fun name? Doesn't sound very fun to me. This would be like update LED or reflect programming state with LED. I need to have like a reflect. Oh, it's on LED. I'll try to make this naming convention consistent, so it should be on, right? And then I can move those together, maybe? Reflect serial input state on LED. Reflect programming state on LED. That's nice. Let's build and program a few times to make sure I didn't break anything. It's receiving, it's forwarding. Forwarding, now they're both reprogramming. Now they're done. Receiving, forwarding. Programming. Done. Okay, didn't break anything. Okay, and then the big run function. Oh yeah, this is the big opportunity to refactor, right? What was NeoPixel on? What? Oh, that's just retaining the blink state. Okay. Shouldn't that be handled by reflect serial input state? Actually, yeah, there's empty braces here. Maybe I could move that other thing here. You still dislike snake case and the bracket style, but I'm going to live with it. You know what helped for me was to just try to follow that convention, even though it was not what I got used to, because now I can fluidly switch between snake case and Pascal case or camel case, and it doesn't bug me as much. Just because I broke this, I broke the habit of being used to one of them. So, like, if I work in a team where then they like camel case or whatever, I don't mind. And go back to my Rust to get my snake case. That's my personal experience, is that breaking out of using one style everywhere made it less of an issue for me. Now, like, as long as it's consistent. The thing that still bugs me is if it's inconsistent. If I made one variable that's breaking the convention, it would bug me. It helps with consistency. I can look at that now and I know it's a value or a function. Functions are values in Rust, so that's not an issue. And I can look at this Pascal case, right? And I know that it's a type. So it's easy for me to tell the difference between a type and a value of a type because of the convention. It's kind of nice. Okay, this is called once, right? We could just recall it again on the timer. Doesn't that make sense? If in self we kept that flag about the blink state, then this would work. So let's do that. Let's take this NeoPixel on and put it into self where it belongs, right? So this, let's call it LED blink state. And then I'm just going to move it into the keyboard. I know it's already a lot of stuff here, but it's okay. We'll survive. It's okay. We'll live. LED blink state. Let's have it start on. Okay, and then self. Okay, and then I can completely move this out. So this would just call self.reflect. How come it won't? Again, when I start partially typing it, it seems like it doesn't want to complete it. Reflect serial input state, right? And then just move that into that function where it belongs. So take this out, go into here, and paste it inside this normal block. And I can get rid of this now. Okay, except for it needs access to the programmer. All right, see where this leads. Is it a hobby project? Yes, it's a hobby project. I have a link for you. You know, I just noticed I have the URL for the more info, and that is the same as notes, right? Yeah, it's the same link. So what you should see when you get there is this overview and what my design parameters are and stretch goals and stuff like that. So I need to update this. It's a little bit out of date. But yeah, making my own keyboard. And I closed it. I shouldn't have done that. I can show you what I have done so far on the PCB side and the schematic. So I ordered some of the parts for this, but instead of going straight to the final product, I'm going to an intermediate board that's kind of like what I have working on this breadboard, but with a few more switches, just to test it out. I've never made my own PCB before, so I'll probably make mistakes. So starting with something small, work out the mistakes, and then make the final product. And I'm sticking with through-hole parts as much as I can because it's easier on my atrocious soldering skills. But I did some of this work yesterday. I got the 3D models loaded for some of these guys, which is kind of nice. But let me not, instead of closing this, let me just minimize it so I can get back to it. You would think that making your own keyboard would be hard, and it could be depending on all the features you want, but if you just want something bare bones and not a whole lot of frills, it's really not that hard these days. This software for doing the schematic and PCB for the hardware side, it's all open source, called KiCad. So I'm not even using it to its full potential. I'm just learning it. So already I'm doing things here you shouldn't, like actually drawing wires between these things rather than just naming the nets. But it's like, you can go back to my VOD and see, like, I struggled a bit at first to figure out how to do this stuff, but it's kind of fun to lay out these traces, and it looks like you're actually really making the board, which you are. I would take the files that are output from this tool and send it to a board house, and a week later it would be shipped back to me. All I need to do is solder on parts. Yeah, if you want complex, you've got QMK, yeah. That's another reason I'm doing this hobby project, because I have this Korn keyboard, and it's running QMK code right now. And I thought about, well, I want to write my own firmware. And then I'm like, well, if I'm going to write my own firmware, why don't I just go that little extra step and actually do the hardware too? You have to be aware of the audio jack as a round front. Yeah, so that's, same thing here. That there's, you have to hang it. So I don't have the right footprint for the jack. I picked a footprint at random that looked close, and for this footprint, they actually drew the silk screen out onto that, which I think is wrong, right? If I hide the silk screen, see that white one? So the other one's the user, right? No, it's the user drawings, I think. No, it's not that. Which one is that? Edge? It's not an edge cut. It's a fab line. Yeah, okay. So this yellow one that's remaining is the silk screen. I don't think it makes sense to have the silk screen draw out that little nub. So I'll probably either update the layout for this part or find an improved layout, because this should be allowed to hang off the edge, right? We really want to be able to move this all the way out to there, right? But I do that now, and I fix my traces and run this the rules checker. It's going to say, oh, you can't draw the silk screen past the edge cut, which I agree. But yeah, I need to find the better footprint for that. We made a Soffel V2 RGB using their Gerber files and built it. You're wanting to write your own firmware and to learn more about Rust. Okay, cool. Yeah. So what I found about the key to writing your own firmware in Rust is the controller selection. So if you just look for RPRS, so this group of people has made a whole bunch of Rust crates just for the Raspberry Pi 2040 microcontroller, right? Now, if instead you picked a different microcontroller and you couldn't find any rust crates, it would be a much more challenging project. But because these fine people have already done a lot of the foundational work, all I really needed to do was pull in their crates. So those are based on Cortex-M. I don't need to worry about all that stuff, but in Cortex-M, someone's already made this board support package. There's hardware abstraction layer, which is based on RP2040. So a lot of the stuff just came for free. Yeah, that Git repo is not mine, but yeah, RPRS, amazing stuff there. And another good thing to look for is find other people who've made keyboards in Rust. So one of the ones I found was this Pinchy keyboard. I need to put that in the right web browser. What's cool about their board is they're using the Pi Pico, and if you see all these pins, there are so many GPIO pins in this board, it's insane. You don't need any diodes on this keyboard. Each key is individually wired to its own GPIO. So and this is just in open source. You can download their PCB files, the Rust code, and you can build this thing. You don't have to do any work other than I guess generate the Gerbers for it and then send it off to a board house and then do the assembly. But yeah, I kept a link for that because they've already got it working, and they mentioned all the libraries that they base it on. Like I'm based on this one too. So a lot of ideas. So it really depends. Do you want a hard challenge or an easy challenge? For the first time, I'm going to go always with the easy challenge and do the hard challenge later. The Pico W has wireless. That sounds really cool. I might look into that. Each key being wired to the controller can really help. Yeah, to do the ghosting, you use these diodes. Actually, the schematic would be better to look at, right? You use a diode here. This is the row. So the row is what you're going to sense on, and it's a weak pull-up. And these are the columns that are grounded when we scan on those columns, right? So if you were to be pressing this key while it's being scanned, this is now ground. And that's why it's oriented with in that direction. So it should force this one low without going back down this way and making switch 2 appear to be pressed as well, right? We don't want that. So these diodes make sure that when we're sensing one column versus the other, that it doesn't cross over to the other column by mistake. But if it's individually wired, it'll never cross over, and so you don't have to worry about that. So the trick here is it's not just based off of the serial input state, is it? It's also based off of if we're programming or not. You know what I can do is I can just say, are we programming or not? Problem is I'm calling this from 2 different places. Is it safe to say that we're never programming if we're receiving stuff from the serial port? No, that's not safe, right? I think what this is saying is the programmer state kind of overrides the serial input state. Only if programming is inactive do we do this stuff. So I think I can just lift this up a level, right? I think so. So this used to say what? Yeah. Okay, so then that's only if it's normal. So then I can just lift this statement out. So cut it from there and then paste it out here. Right? Yeah. I like it. The side effect will be if the host sends some serial port data while we're programming, it will blink. It will blink. Do I care about that? I don't think I do. Because we shouldn't be sending any more data while it's programming. I think this is safe. Let's try it out. Control C. There we go. It's receiving, now it's forwarding. So again, when I program one controller, it's also forwarding the programming to the other controller, and then they both commit the program simultaneously. The sending over the USB is very fast. That's what you see in this very front. And then the forwarding over this slower UART line is what we're seeing most of the time accounted for. And then the actual final programming happens really fast. Uh-oh. Oh, because the USB isn't fully connected yet, right? Oh, that's odd. Oh, I know why. Okay, it's flipping the bit not based off of the timer anymore. That's a bug. it's at a every time it receives a greeting, it's also toggling the LED. Yeah, so this is assuming that's only called on timer update. And although it's true here, it's not true here. So probably that means that I don't want to flip the LED blink state. I want to just take this part out and move it over here. And just invert it like that. And then inside here, I just want to say if and remove the false true. Yeah, that's better. Build that. Control C, program. Okay. It's nice to see that the programming is now solid. We're not seeing any issues there. Knock on wood. Okay, good. And I can reset this guy, right? Yeah. We're good. Pressing buttons there works, and then if I unplug that and plug this one in, now it's coming from the peer instead of the main board. Oh, did I confuse my bus again? Yeah. I have this like really cheap USB bus thing that gets confused sometimes. And I just have to reset my camera whenever I unplug it and plug it back in. There we go. Fixed. Alright. More refactoring, or is that enough for a good check-in now? This is probably a good amount of check-in, so git commit. Refactoring. Okay, what did that change? Move LED blink state. Into the keyboard. Type. Okay, this change... Looks like we added code here, but I think it's just because I moved things around. Yeah, it's just there's a bunch of stuff moved around. So it was extract this function, right? okay. And then the next one too. Okay, what else? That's basically it, right? Yep. Then we're done. Next round. Close up the new. Okay, process serial input's looking really nice now. It's just a loop over the state machine. We break out when we're no longer consuming anything. This is nice to read now. So I can button that one up. That one's looking good. This one looks nice. You know what I could do here? I could just have this match return a color and call NeoPixel write once, right? Because this is always writing some color. So why don't I do that? Let color equal, and then semicolon, enter, paste, and then just put color here. And then these just get reduced to the color. So down to this. This would look really nice. And much more readable, right? It's funny how like a semicolon right there can, if I just add this semicolon here, it makes it look like there's an error on the next line. And someone new to Rust would be confused why it says match arms have incompatible types. It's because that semicolon now basically hides these values and they're not assigned anything. Whereas if I remove that semicolon, now these become the result of this entire expression if we go down that match arm of normal, right? So it's what goes into color. That's what goes into color, right? But putting a semicolon right there kind of is like a putting a wall and saying that these are not going to be assigned to color at all. They're just going to be values that are temporary that just get dropped. And I think that's why if you mouse over this, it'll tell you that, whoops, mouse over it, scroll down. It'll say this is found to be of type empty parentheses, basically telling you there's no value, so this is being lost. Okay, that's cool. So we'll button that one up. Same thing here. Let color equal that, and then we write the color down here. Oh, you know what? I realized that I messed up here. Well, is black with a brightness of 8? That should be 8. And I should make that a constant, actually. That's the color, that's the brightness that I'm choosing. Is black brightness 8 actually off? I guess we can test to make sure. This, right? Yeah, let's make a constant out of this. Let's call it LED brightness. And what type is it? U8. How bright to make the LED when it is turned on. Okay. These are good. Handle commands. I like it. That looks nice. Close that up. Run. I think we're down to the run function is the only thing that needs to be fixed. Let me make sure before we tackle the run function that it's built and working. Receiving, forwarding. And flashing. Okay, one more time. Make sure it didn't kill the programmer. Looks good to me. I just noticed that these sectors are decimal, whereas you can see if I move my head, that's hexadecimal. That's inconsistent. I hate inconsistency. I have to fix that. Percent or colon 08x, I think. Right? Is that what I think that's what I'm using? Yes. Why is that lowercase? That should be uppercase. All right. We don't need dump. Okay, save that. Okay, check this in. Commit another refactoring step. Autosave. Oh, that's a problem. I don't want to stage that one. That needs to be ignored. That's just because I have it open in KiCad. Okay, so define this constant or extract. You don't have to say it's a constant because we know by the bit being all in capitals that it's a constant. Okay, we'll just say delete redundant code from LED update functions. Okay, now I get to tackle the run function, which is really huge. Okay. That's the wrong one. We'll get to programmer in a bit. It's in keyboard. Yeah, this run function is really big. It's okay at the beginning. We're setting up some timers, right? And then we have this main event loop. Okay, this one is updating whether or not the blink speed, right? Depending on if we're the primary controller or not. Let me at least comment it. Update LED blink rate if our role has changed. Okay, and then I think I'm going to remove everything out of this wood block. So this would be just update LED if blink timer triggers. I think we're just going to take this entire thing out. So how far does that go? If that's unreachable, then what if I just say we don't care what the error is? We're going to do nothing about it. And then we go all the way down and we just delete a few lines and we're done, right? And then that should automatically outdent. It didn't. Why didn't it? Too many brackets deleted? Not enough brackets deleted. Yeah, extra bracket, delete that. Cool. So outdented all that code. Aha. Then this doesn't need to be a match. It can just be an if let okay. Neat. We don't need to say we are idle because this is the idle loop, the main event loop. So do any polling we need to do. Well, it better be to say poll USB keys, key matrix, and serial and UART serial port. That's implicit in the name. Poll USB key matrix and UART. We connect the USB send a greeting to the secondary board if we haven't yet. The order of these things doesn't really matter, right? If connected to USB, collect whole lines received from the peer and log them. Otherwise, process data as if we had received from the host serial bus to support programming. So this is wrong now. It's I fixed this to be collect whole lines from the peer and log them. No, it should not say that. It should say if we are the primary controller. Collect whole lines received and log them. Otherwise, process data as if we'd received it from the host serial bus, e.g., support programming. Okay, so this whole thing, right, could be extracted. What to call this function? And I can say programmer equals, right? Oh, wait a minute. I can't. Does this actually compile as is, or do I need to? I do need to adjust it because of this. Because it's borrowing. Yeah, we can't do that. I think we have to pass in and out. Just need to do that. What to call it, though? Process peer data. There we go. Actually, now that I think about it, it's just polling, right? And that really goes there. So let's just call it poll, and we'll move it up to where all the other polling is done. Poll peer. Serial. Peer input? There's host input and peer input, right? But then why is it different from poll peer serial? Because the serial port feeds into the input, peer input. Can it be just combined? No, this handles transmit and receive. Wait. Does that get referenced anywhere else? No. Okay. Do I even need that ring buffer anymore? I might not even need this ring buffer. Wait. I think it's confused because of my errors. How about we'll undo for a bit? Let's not extract this quite yet. Oh, but I'm in the middle of doing it. Okay, well, let me fix the errors first. Okay, so we just get both of them in and then we return both of them. So input and an output. So in and then out. And then that it just needs to be mutable. Oh, what did I move here? Oh, this is mutable self. There we go. Okay. Back to my question from a minute ago. I think this RX reader, where is it referenced? Okay, so if I combine this poll peer input with poll peer serial, it all fits into here, doesn't it? And then I don't need that ring buffer at all. Actually, maybe I still need that ring buffer, right? Because, no, hold on, I don't need it. I don't think I need it. Because it's just going to get some slice, and it's going to either extend the peer log, or it's going to put it into received. Yeah, okay, then this is even easier. So if I move this up to here, and then just make this poll peer serial instead, and delete that, and then take this signature and paste it here, and just replace the name, and then take this code and just plop it into that case. That should just, that lets me get rid of an entire ring buffer, right? So I put it right in here. This needs to move down to here. Yeah. Cool, then I don't even need that ring buffer. So that ring buffer's never used. It should warn me that I'm not using it now. Okay, it is, we're still using it because this bytes needs to, hold on, why is there a while loop here? I don't need this while loop. Remove the while loop and remove the poll. We just have bytes. Oh, bytes becomes a slice. So then it really is num bytes. And we need to reassemble bytes. Let bytes equal the slice of buffer from out to num bytes. I don't need that anymore. Cool, now it's going to warn me I don't need that. Ooh, look at that. I got rid of a ring buffer. Woohoo! And I don't need it there. And I don't need to construct it. Yes. Excellent. Excellent. Now, I could extract that back to be another method if I wanted to, but I can combine I should combine these two together. There we go. I did it, chat. So if we're the primary controller, collect whole lines, receive them, pair, and log them. Space. Otherwise, process the data. Okay, so here's our buffer. We read it directly from the serial port now. We don't need a ring buffer because we consume it immediately. We either write it back out to where to our own log, which is another ring buffer anyway, or we put it right into our received. That is too generic. Let me rename that. So this is received from, whoop, what happened? Received from serial. Well, received from, oh, that's the problem. I don't know what to call it. Received from host? Problem is I have two serial ports, right? I have the UART and then I have the USB serial. So it could be received from either one. But if I say received from serial, it's ambiguous which serial port it's received from. Let's, instead of focusing on where it's received from, we'll call it like the, it's what commands us, right? So this is controller. Received from control, no. Controller is an overloaded term, so not controller. What to call this? Like command bytes or something? Or host bytes? I don't know what to call this. Host buffer? Control buffer? How about call it control buffer? That did not go where I thought it did. Control buffer. And then we'll keep it alphabetized. So that goes up there. Control buffer goes up here. I like to keep things alphabetical, which means that I need to, okay, I need to do a little bit more sorting. Row goes down. Oh, this is really unsorted, isn't it? Let's sort them. K becomes for 4L. N. Looking okay. Okay, that looks good. Let me fix the declaration order. Yeah, I let this get kind of too out of hand. Looks good now. Okay. Now I have to start thinking about maybe breaking up the keyboard state. There's just a lot of junk in it. And some of them, like, some of these are similar concerns, like maybe this could be called key matrix or something. Just for organization. Okay, control buffer. There's where we declare it. There's where we initialize it. There's where we fill it. If we're the primary, no, if we're the secondary controller, we fill it here. Here's where we fill it if we're the primary controller. Here's where we process it. Okay, so it's not serial input anymore. It's process control buffer. That's the real name of it. I don't see where that is. Can I reset? Is it because it's inside of these? Yes, somewhere inside. I don't see what line number we're on. Oh, it's right here. Okay, I'm just blind. Yeah, so we drop them and drain them at the end of process. Looks good to me. Sanity check. Build and flash a few times. Wait. Why did it print that? Oh, okay. It's not connected to the serial port right now? Why not? I don't get it. Try again. There we go. I think that's a Windows thing. Sometimes it just pauses connecting. You know what I'm doing? I think I'm about doing is adding a little delay on the primary host, just so I can see it print all the things and then say it's about to reflash itself. Just for my own, like, sanity. Cool. All right. Everything is good. Unstage that. Okay. Stage that. Git commit. Okay, a bunch of changes here. I renamed received to control buffer. This is too generic. What else did I do? I sort the members of keyboard. I removed the peer receive ring buffer. Unnecessary peer receive ring buffer. Okay. As the ring buffer going away, that's some sorting I'm doing there. Oh, right. So I merged poll peer serial and with what I extracted out of the run. Okay, so basically I added to poll peer serial. Right. By removing the ring buffer, I just filled the code directly into there. So move code previously fed by peer receive ring buffer directly into whatever this is called, poll peer serial. Yeah. Where the data from the peer is actually received. Hey there, the tattoo technologist. Is the GitHub repo for my code so far public? No, because I don't have permission to make this open source. So this is closed source you're seeing. Love to troll through and have a look at some point. The only way to do that would be to watch the stream or the VODs. They're in my YouTube, though. You didn't see the link in the notes? I should probably add that in there. So all of my VODs I will archive in YouTube. And I made a playlist there the other day, so all the ones up to yesterday are in the YouTube. I wish I could release this as open source, but I need to go through a lengthy process with work to allow me to do that. So I can kind of live code it, but I have to retain all of the copyright and the license is I can't open source it. I have to retain what is it called when you're not allowed to license code into the into by an open source license. Is that unlicensed or something? Kind of stupid. Well, I don't want to say anything bad about that, but there's a process I have to go through, and it's a really long one. And I've heard that it's the process is improving, and hopefully it won't be a problem in a few years, right? It doesn't, to me, it doesn't really make sense. It's overprotective, but yeah, I'm not even really allowed to mention who I work for, so let's leave it at that. Pull peer serial, incorporated the code there. So this is just renaming stuff. I should mention that I renamed this, right? Along with this. Rename. So that said, I can always promote other open source projects, and that's what I've been doing in my notes, right? Check out the Pinchy keyboard, right? There are also a few other keyboards in the links. So there's the Rusty Keys keyboard. Everything that I'm learning during my hobby, if I keep the links, I'll put them in my notebook. And the notebook is just my notes, so there's no code there. So it's not open source. See how that works? I agree, John Mega, but employment is weird sometimes. Okay, I renamed it to process control buffer. So, you know, I did get permission to stream teaching Rust, which is what I'm doing, and doing programming challenges like Advent of Code. But as long as it's only for that purpose, it's fine. All right, they were done there. You know, sometimes I talk too much. It's the habit I get into in streaming, is where I connect brain directly to mouth. This is looking nice and slick now, although it's still 600 lines. Makes me think like I should move some of the responsibility. I should break this up, right? Because there are different concerns here. There's the serial port. There's the programmer. I already moved part of the programmer out, but not all of it. Right, there's the point where we connect to the programmer to run. It's like a state machine. We run its next function and we get a new programmer back out. The next state of the programmer. Same thing for the serial input, which is now called the controller buffer. Well, it's called the peer serial. Okay, it's still called serial input state. Should I rename that? That should probably be renamed to something like controller state or control state. Yeah, that should be renamed, I think, to control state. Wait a minute, I'm second guessing myself. It really is tied to what we get on the serial port, though. But I did rename it from received to control buffer. This is the control state. We're either normal mode, call it controller state. That kind of makes sense. So where is this all mentioned now? Wait, I have a... Oh, I have to like save all or something, right? Yeah, all references. Yeah, so let's just rename it controller state. Ah. When I hit the wrong key, it like messes up. There we go. Refresh. Save that, refresh. So with Rust and refactoring, I've been following this pattern where I just keep iterating until when I look at the code, I can actually read it again. I figure that that's a pretty decent way of doing it. When I start to smile when I look at the code rather than frown, then I figure my work is done. What the heck is this? Oh, it's just called serial input. Should I rename the whole module then? I think I should, so let's do it. Rename the whole module controller state. Beep beep. And I do want to do that, and I want to save all because I am a madman. So it should have changed the mod, and it did. Okay. Save everything. Save all the things. Control state or controller state? Controller state. Because I think of it either as if the host is controlling the keyboard, then it works. Or if it's just the state of the overall keyboard controller, it also works. So even though it's maybe somewhat ambiguous, it makes sense to me. It's our overall state, whether we're driven by the host or not. And there are currently 3 states. We're either in the normal state, or we're receiving a program size, or we're receiving a program. That's it. When we're done receiving the program, we go back to the normal state. We do have a programmer that runs independently now, and it has its own state. It's either inactive, forwarding, pausing, or committing. I think it works. There we go. Once more, just to test the programmer itself. It's looking good. Okay. Let's check it in. More refactoring. Hope you like refactoring, because that's what this channel is all about today. Or maybe you just like hearing the sound of my voice. That's what a lot of people told me when I was streaming my game development. It wasn't that they really cared about my game so much, it was that they liked the sound of my voice. And I'm like, I have to listen to it all the time. I have no choice. If you have a choice and you're still listening to it, I mean, that's great. If you don't like my voice, you're probably not listening to me, and no hard feelings. So that just got renamed. Yeah, that's all I did? It was just rename that? I guess so. I renamed it everywhere. So I don't need a bullet point, do I? All right. Main's looking good. Keyboard's looking good now, right? Run is kind of long. So one pattern I see is that these could just be functions, methods of self, whose name kind of is derived from the comment, right? The only thing that stands in the way of that are these local variables. But as long as those could be borrowed mutably, I think it would still work. So like this one needs was primary controller and the blink timer. This one needs the programmer. This one needs the control state and the programmer. Let's try it. So I will take this And I will say extract into function. I'm going to call this function poll. And I think this needs to have that same in-out pattern that I was using before, right? Where I kind of do this, this equals, take off the dereferences and take off the references. Like that. And it just does the same pattern here. Right there. And that actually, this can just, I can just shortcut it like this. Okay, and that, right? What's wrong here? Cannot find controller. Oh, that's what someone was saying, like there I was inconsistent on the name. So I'm saying control state somewhere. Maybe this, hopefully this is the only place where I was doing that. Let's find it. Am I using control state anywhere? I am. Okay, let's fix that. This should be controller. Fix that inconsistency. I hate inconsistencies. Okay, see ya, Jalmega. Oh, it was a tattoo technologist who did it. Yes, so you deserve a point. I haven't been doing this enough lately. You get a point. How about that? A useless internet point. All yours. Okay, my poll is not correct. What did I move by accident? Move is... It's moved because of this... Oh, right, because it's self, it should be mutable reference to self. The refactoring tool does that sometimes, and I don't know why. Oh, see a tattooed technologist? Now that you have your useless internet point, it's time to work. I think I'm just going to continue to do these little refactorings so I can get rid of these comments, right? This one's a good one to do. Extract into function. This one's called what? It depends on the comment. Comment is update LED blink rate. Okay. Update LED blink rate. Mutable reference to self. Easy. That was almost too easy. Let's do this one. This is send greetings. Again, I think I'm just hitting... Instead of hitting underscore, I'm hitting something else. Again, that needs to be mutable self. Cool. A couple more. Update LED if blink timer triggers. So this is like... blink LED or something.
Have a minute?
Yeah, just a minute. In a minute, I'll give you a minute.
Okay.
Blink LED. I mean, that's it, right? Now, theoretically, I should be able to get rid of the comments and it's still readable. So if we read it, it's update LED blink rate, then blink LED, then poll, then send greetings, then move the programmer to the next state. I think that's awesome. I can read it. It should still work. I didn't break anything, hopefully. I need to take a break in a minute because I was asked by one of my kids for a minute. I will give them exactly 60 seconds and no more. Okay, this is the Windows. Hey, it's a good time for a break because I have to wait for this to get unstuck anyway. I'll be right. Actually, what do I put when I'm on a break? How about I'll put it in. I'll make something look really cool in the 3D viewer, and then over here, I need to have like this anyway, right? Taking a quick break. BRB. And then I'll just put this in the foreground because it looks cool. There we go. I'll be right back. I'm back. Look at that board. Isn't that sweet? It's only got 6 keys, but that's okay. Beep beep. Beep beep, wake up. Wake up, chat. Check that in. Git commit. So this is extract functions for blocks of main loop. All right. So our run should look really nice now, right? I do need to sort the names of the functions. It might look better if I was able to like move some of this stuff into self. We can't do that with these states, but maybe the was could be moved into there. Does that really matter? Do I even need those? I guess I do. I do. Okay, that's a reason enough to move this in. Okay, I'm gonna do it. I'm going to put that into here. Bool. Initialize it to false. Okay, and then I'm gonna delete it down here. And this all here becomes self dot. Nice. Move that thing into keyboard. Move was primary controller into keyboard. Keyboard. Okay, so there was a way to like collapse everything. I forget what the shortcut was. It's like collapse. Or what is it? It's not collapse. Is it outline? Fold? Fold all. That's what it is. Fold all, because what I want to look at are these functions, and I want to kind of put them in alphabetical order. So like the U goes after S, right? This one goes after here. I don't know why there's that line at the top now. Am I confusing VS Code? Blink LED should go at the top. Okay. Just sorting functions. No big deal. I'd like to know why that bar is on the top. Okay. Run, poll comes before run. Okay. So I think I got it in the correct order now. There's that bar tracing across the top, and I don't know what it means. I don't know what that. I don't know what you mean, VS Code. Ba-da. Cool. One more time. Ba-da. All right, I'm happy. Okay, that is going to be a mess. Oh, it stopped whatever it was. So this is just sort functions of keyboard. It's going to be an ugly diff. That's okay. I think I'm getting to the end of how much refactoring I feel like doing today. So, unfold all. Yeah, let's see. Is there any... Can I break up keyboard into subparts? I think this is what this is telling me, that this, all these pieces of keyboard, do they really depend on, are they interrelated? Some of the stuff could go with, like, if I break off one just for key scanning, like previous report would go with the previous keys, would go with key scanning. So would keyboard report, right? Where is that actually used? Why are we holding on to that? I think I killed my Rust analyzer. Restart it. There we go. It's confused. There we go. It just took a while. Keyboard report is what I cared about. There we go. Keyboard report. Interesting. So we take a report out. We provide it to the USB and then we place it back in. Keyboard report. Okay, comes from USB-D HID. Oh, I see. It's as if we couldn't send it. Okay, so we start with no keyboard report. Then, if we have a keyboard report to send, wait, do we always have a keyboard report to send? Wait a minute, we're always sending it to the host? Interesting. I didn't know I was doing that. It's always trying to send the host a keyboard report. Shouldn't we only do that if it changes? Like, shouldn't it be inside of here? Maybe we should send one at the beginning if the host hasn't heard it, but after that, we only need to do that if it changes, right? So that should kind of be in here. Maybe what I do is I get rid of this previous report key codes, and that just goes into keyboard report. Is that this thing implements compare? Actually, I don't know. That's a huge attribute. I don't know what that means. Maybe I did it this way because this key codes, I could declare it as, not even declaring it as partial equal. I guess it's automatically implemented. It must be, right? This thing must implement partial equal like automatically, probably because its members do. Otherwise, this comparison wouldn't work. Oh, right. I think that there's a bug in this calculation because sometimes when it bounces, we see a much smaller number. Get counter start because now. I wonder if that's because this takes time to do, and I should do that. Oh no, it doesn't matter if it takes time to do. Yeah, I don't know why sometimes they get a small number for this. This is scans per second, right? This is in microseconds, that's why we have to multiply by 1,000,000. Can I have an overflow here? It's a 64-bit integer, so it should be fine. I don't know. I don't know why we get a small number. Anyway, moving on. The whole point of this was to see what is part of this key scanning, right? Yeah, like the columns, the row, the keyboard report, the previous report, that could be extracted out, maybe under like another module. How about I leave this for later? And because I've been streaming for 3 hours 20 minutes, I can do a little bit of work on the PCB, I guess. Because I have the I've ordered the part for that, and I want to get the correct layout, and I want to get the, what is it called? The library for this layout. Library for all the parts I got, so maybe I'll do that now. So we're all done here, I think. I'm going to switch to the PCB, and there's a change? I didn't mean to make a change. Let's close that without changes. Did I accidentally check in that file? I must have. When did I do that? I accidentally checked in a temporary file at one point. Oh, right there. Do I bother fixing that? I guess I just fix it now, so yeah. I want to ignore that if it... So that begins with autosave. So let's check in the delete and then go to dot git ignore and delete anything that is autosave. Like, we'll just say fix accidental check-in of a PCB temporary file. All right, all right. The library I wanted to look for was the DigiKey, because I'm ordering from DigiKey, right? DigiKey KiCad library. This one. I want to get that library. Let me do this. Let me read this README. Should be considered unmaintained, but will remain here. It's 5 months old. Look at the current issues. Currently unable to maintain this? What? Oh, that's sad. So, DigiKey released this, but it's not up to date with KiCad 6. Well, maybe it's not worth it then. Well, that's sad. So that was... So this is years old. Does that mean this introducing it is going to be old too? What's the date on this thing? It's probably old. Okay, well, that's sad. Maybe I won't be going and cloning this repo if it's unmaintained. Let's look at the issues. Maintaining the library. What's this? Oh, this is someone else's fork of it. How come they didn't update the right README then? Okay, so someone had migrated it and saved it in KiCad 6 format. Wait a minute, there's a pull request open? View pull request. How old is this pull request? It's from February? Well, I mean, I guess it makes sense because it's not maintained. I mean, I could take the guy's fork, I guess. How could I take someone's fork? They need that fork. You got 2 thumbs up. Anybody else? Okay. How about this one? Hmm. I'm wondering if I only really need the symbol for the TRS connector, maybe I just make it myself. Because all these other ones are good. Maybe I just make my own symbol for this thing. I have the datasheet for it. Then I don't need to mess with importing that whole library. The only thing I'd be missing probably is the 3D model for that connector. But I could look that up separately, right? Where's my parts? So I'm using this connector. Do I have it already in datasheets? Oh, look, I already did it. So here's the connector. So I could just draw, like, just take this and put it directly in as a symbol. It's giving me everything I need to know about this, right? 3.5 to there. How big are these? What's that? Oh, 1.5 times 0.8. Okay, I can do that. Maybe that's what I do today for PCB hour, is import that symbol. Okay, so then I need to go back to the schematic. I need to go to that symbol, edit it. And okay, yeah, first things first, I have to actually make the footprint. Footprint editor. I don't remember, did I make my own library here for under project? I don't think I did. Where did I... Oh, it was schematic editor I did that, right? Not schematic, a symbol editor. I made my own library here for project. Yeah. This guy. Right? So I can do the same thing here for footprint editor. I can make a new library. New library. Project level. I'm just going to call it project. Project. So that should have created something over here. I'm expecting that to show up. Do I actually need to do a new symbol? Let's see. So new empty. What's a footprint wizard? Beep beep. Footprint generator. Whoa. I don't think I'm going to use this footprint generator. I think I'm just going to do new empty footprint. It's a through hole part. Footprint name is going to be named after this part. So zoom out a bit. It's this number here. So this is TRS connector. that number. Through hole. There we go. Move some of this stuff out of the way. Okay, so I need to make a rectangle about that big. So dimensions are 6.6 between that. What about the outer dimensions? They don't give an outer dimension for that dotted line that on there, but they do here. Okay, so that's 12.4 by 7. 12.4 by 7. Okay, we can do that. I need the grid to be down to 1 because I need 12.4 by 7. There we go. Move that and center it. I wish it could like auto... Can I auto center this? Ah, shoot. I need to be clicking this tool. Can I like tell it to center this? Move, rotate, properties. I guess I can, in the properties, I can get a start point. Which libraries do you recommend for stepping in Rust development on RP 2040? I recommend the libraries from the RPRS group, so RP-RS. Check out this GitHub repo. Or you can just look at the released crates for it. I'm using all of these, well, not all of them. I'm using the RP Hell and the RP 2040 Boot 2, and I started with the project template. That was a way to kind of get jump started using the peripheral access crate. So definitely recommend checking this group out. This project template is a good starting point, actually. So you can get something that gets up and running and it blinks an LED or something, I think. And it like walks you through the entire process, which is kind of nice. Okay, back to here. Okay, lack of a centering tool. I guess I just divide by 2, so if it's 12 point, half of 12.4 is 6.2. 6.2 by 3.5. Negative 6.2 and negative 3.5. And then positive for the endpoint. There we go, I've centered it. Okay, that's the silk screen. Now I want to add a user drawing to depict how far it extends out. So that's 2.5 out from here. And then how deep? Give me a dimension for that? Oh, it's just as tall. Okay, so it's just, no, but how, this thickness here, where do I get that? I guess it's the outer radius, right? I guess if this is a circle and that's 7, it's 7. No, that's the... Oh, it's just 6. So that means it's 1 millimeter in. So if we're at... So we need to go down to... half, 0.5 from here, right? So negative 3. Yeah, so... Oh! 0.3. like right there. I keep hitting the wrong thing. I'll just draw it. And I don't draw like that. I click and then draw. Let's just edit it. Obviously, I'm not very good at this, but that's okay. I only need to do this once. So 2.5. So can I do math in these boxes? 6.2, right? Can I do that minus 2.5? Ooh, I can. That actually worked. And this is like this plus 2.5. Wow, it actually works. I like it. Okay, so then let me get the y coordinate of this thing. Negative 3.5. So it's that plus 0.5. So it's minus negative 3 plus that whole dimension, which is 6. There we go. I did it. So does that look right? Dimensions are millimeters, I hope. I guess we'll find out if I have the units correct or not. I'd like to find out early, though. Maybe it's just obvious to anyone reading this, but it's not obvious to me. It does mention it somewhere. Dimensions are in millimeters. Okay, got it. Okay, so from the outer outline, we're going to draw a through hole that's 0.8, a center on Y, and X is 2 across from the left point here, which is at negative 4.2. Right there is a pad. 4.2 right there. And the other one is, well, actually, we can just edit that one and make a copy of it, right? Because this just needs to be a non-plated through-hole mechanical, right? Circular, and the size is 0.8. There we go. And then we need another one 7 over from that. So if that is... Okay, I can't do math. Let me duplicate that and put it there, and then grab that and then add 7 to it over here. Plus 7. There, did it. Does that look right? So it should be 9 over from here. So like 3.2. That doesn't sound right. I think these aren't placed quite right. Okay, I see what's wrong. No, I don't see what's wrong. This one's placed correctly. That's 2 over, like it says. But 9, the other one should be 9 over. And if that is negative 6.2, that's not correct. Negative 6.2 plus 9. It's still not doing it right. What am I doing wrong here? Maybe that is correct. And I just can't do math. Actually, I think that is correct, and I just can't do my math. Maybe this thing is, it looks lopsided. But actually, it kind of looks lopsided here too. Actually, that might be correct. Okay. Assuming that's correct, then I just need to draw these pads, right? So at 3.5 over, and how far down? It's 6.6. So at 3.3, at negative 3.3 by 3.5 from there, I need another pad. It's going to be a through hole, rectangular, how come I can't do a rectangular hole? Okay, do I have to Google that? Because that does need to be a rectangular hole. Can you not make a rectangular hole? Anyway, the size is 1.5 by 0.8. Okay, I guess I need to make it slightly bigger. So let me add 4 in each dimension. Maybe you don't need 4, maybe subtract 1? How about just 2? Sure. That should be pads, right? Oh, because it's selected. Yeah, alright. Now to where to physically place it. I'll have to figure out why I can't make a rectangular hole for it. Why it has to have to be oval. Anyway, it's 3.5 by 3.3. I keep forgetting this point here. Negative 6.2, got it. Negative 6.2 plus 3.5. Okay, there's one hole, one through hole, another one on the opposite side. So duplicate that and put it at positive 3.3. All right. Another one exactly here. 12.3 from that end. Okay, so duplicate, rotate. This point being 6.2 and 12.3. Negative 6.2 plus 12.3. There we go. Okay, and then 2 more. 11.5 and 5. Okay, now it's getting... Now my brain's starting to hurt. X dimension first. It is 11.5. So it was negative 6.2, right? Plus 11.5. That looks right. Lost my place. Yeah, okay. Oh, I don't have the vertical position right. 5.7. Oh, that's wrong. Oh, half of that. Half of that would... Can I just divide by 2? I can! What is half of that? 2.85. Okay. So put this one at negative 2.85. There. I mean, it's looking good except for the fact that the interior of the hole is oval. Hit save on this. Inspect, measure. Oh, that's not right. It should be 0.8. Oh, I increased it. Right. The cutout oval is at the 0.8 mark. Yeah, that makes sense. I kind of want to look at what I had in the PCB now. Oh, I think it was surface mount part. Yeah. So if I 3D view that, those are pads there. Right? They're not through holes. Okay. I saved that, right? So then let me kind of look for other TRS. That's the only one I have. Audio jack? Yeah. Can I pick a through hole part and take a look at it? I don't know. Oh, right. This is the problem. I couldn't find this last time, right? The ones that were there were all surface mount, I guess. What about this? Oh no, those are holes. Interesting. They're not drawn. They are ovals. So maybe I should just change mine to be oval and not rectangular. I'm curious now, what are the dimensions of some of these ovals? .4 by 1.4 versus what? 1.5 by 0.8. I mean, it's just a little smaller. I don't know how to correlate. How about this one? How big is that? 2 by 1, okay. So maybe I just make them oval. I mean, I guess I'll do that. So TRS. Oval it is. I have a feeling I should make it wider though. So let's do that. 9 by 0.2. Oval. What are the other options here? What's trapezoidal? Huh. Rounded rectangle? Interesting. Okay, just gonna go with oval. Make these all dimensions the same. So oval. I don't think I can change multiple at once with this tool. I should have kind of I should have just figured this out from the beginning with one of them and then duplicated it. You know what the hard part of this is going to be making the 3D model. I don't even know how to do that. I'll have to dust off my Blender skills and see if how I get the 3D model in from Blender here. Okay, well, it's at least something to start with. That's the part that I ordered. Now, let me get the pin out correctly. Correct. So, pin 1 is the sheath. So it goes sheath, ring, ring, tip. So that's, okay, let's just do, so that's S or sheath. So edit that. 1. I'll just have to remember that. What's this custom shape properties? Huh. Anyway, is that correct? 6.1? Anyway. 2 is up here. And then this is 3. And these are both 4. Okay, so how, because the 3D view is just going to show me the pad, right? I wonder if I need to make these holes a little bit bigger. Also, I want to cut the, I don't want the silk screen to overlay the copper there. So I need to fix that. How do I divide this? Correct. Create polygon, create zone, create lines. Okay, now can I move individual lines? I can. Okay, so that can I... Whoa. Okay, so I can delete that one then. Cut. So this can go out to here, and then let me duplicate that. Not to say there or some or so. There we go. All right. Let me just delete this line. Can I do a shift select? I can. And duplicate them and move them down to here. Excellent. Okay, and then I need to cut this line up. It's right on top of the copper there. So what if I do this kind of a thing? Actually, I'm just going to delete that line. duplicate this line and put it down here. I think that's right. Can I put something like right on there? I think I can. So I can make a tiny corner there. Duplicate that and rotate it and put it down here in this corner. Look at that. I'm like an artist now. Save that. Now the silk screen is not overlapping the copper. And let's view it. That looks nice. The only way to really know if this is good would be to have the board made out with this layout, or I guess what I can do is print it to paper and then actually drill the holes myself and see if the part fits through it when I get it. That's probably cheaper to do than to have a PCB printed with this symbol on it, or this layout on it, right? Make sure everything lines up. I think that's what I'm going to do. So when I get this part in the mail, I'm going to print this out on the paper and I'll see if it fits. These look small to me. Okay, I think that's the wrong dimension. Should be 1.2. Oh, because I copied 1.8 down here. What is that? I don't know what that is. This is the PCB layout. It should be 1.2, not 0.8. So what is this then? What are these holes? Are they not on the bottom? Good thing I'm gonna print it out on paper and see. I'm gonna guess that I do need 1.2s there instead of 0.8. So this should be 1.2. 1.2. Okay, I think the position's good. I forget which of these is which. Is that the silk screen one? Yes. Okay. Let's move that to the middle. And this one is what, a user drawing? Or ECO? No. What is that one? A fab marker? Can I just put it above it? And move this one below? That's what I'm going to do. Alright. Save. How do I add a 3D model to this? I have no idea. Be under footprint properties probably, right? 3D models. Okay, so then how do I add a 3D model? All files. So what? Oh, it's .3D shapes? Huh. Don't suppose they just have a shape, I can just throw in there for now. Connector, 3D shapes, no. Barrel jack, here we go. I have no idea which of these I want. How about we just try the first one? Huh. Oh, I see. Yeah. So what's the difference between step and WRL? I have no idea. It just looks lighter to me. Okay. Obviously not the right one. Anything closer? Don't think so. What's Molex again? What does that look like? Huh. Oh, right. The jumpers. Okay, not Molex. Don't know what these are. Okay, pin header, pin sockets, RJ, SATA, USB. Yeah. Make it look like a resistor. Surface mount resistor. It's a little small, but there it is. Let's just delete that model. Okay. Figure out the 3D model some other time. I at least want to put this on my board, even though I don't have a 3D model for it, and I don't know if the dimensions are correct. Let me save that. So I'm going to go back to... Do I want to make a symbol for it? I kind of want to duplicate the symbol I have. No, I don't need to do that. I can just go to the schematic editor and I can go to this copy here and then just change the footprint. That's what I want to do. And the footprint's from my project library. There it is. So save that, go to this PCB. Does it automatically update? Let's see. View 3D viewer. Oh, I didn't need to do that. I can just look at that to see it's not updated. So update footprint from library, right? It didn't update. Oh, that had a 3.5 millimeter jack? I can actually use that as a placeholder for now if I fix that path. But I think the thing is I need to delete this and then add it back in because I don't know a better, a faster way to do it. So I'm going to cut it and then update from schematic. And there's my jack. Okay, cool. So let's delete all of these traces. Okay, and then let's move this so that it's right there, right aligned there. I'm gonna cut. That's actually perfect, right? Because it's cut right past the silk screen. It doesn't really matter where I place it. Let's line it up sort of in between the diodes, I guess. Okay, so back to the data sheet. I wanted power last, right? And ground first. So ground on 4? Wait, is that right? Yeah. Okay. Just trying to see how this works. Really, what I really want to do is on the back copper put a wire between them, and then also go up to the ground up here. I forget which one it is. The one marked ground. Oh, it was over. Okay, I need to go back. Let's find ground. Oh, it's middle click does that, or right click. Okay. I thought I put ground up here. How come it's not marked as ground? Yeah, pin 26. Why is it marked as pad T? I don't know. Going up to pad 26. Okay, so let's go around. Yeah, I can't go through another trace like that, right? I can do that. Ooh. Can I cut across here? And then go to there? Yeah. Okay, and then pin 1 to power, which is which one? 24. Okay. Ooh, how am I going to get there? I guess by going up. Front. Copper. Oops. I hit the wrong key there. Try again. That should be fine, I think. It's not connecting all the way through, though. Why not? That's not connecting all the way through either. I guess I have to mark them in a certain way. I don't know how to do that yet. So ring 1 is 3. So that goes to D1, which is pin 3. Okay, let's move this over to here then. I should do 2 first. 2 is ring 2 to D0. Just pin 2. Ah, This wrong again. Okay. What is that line? Is that part of the pad? What's that single line there? I don't know what that is, but I might have to move my trace out of the way of that. It wouldn't have let me draw that if it was in the way, right? Anyway. Why is it allowing me to draw on top of that other one? I don't know. Ah. I have to move these. Okay, can I just select and move these? Actually, what I want to do is just make it longer. All the way up to there. Yeah, that worked. Okay, and then I want to move this one over. Let's get rid of this ugly thing. Okay, we'll have to figure out how to annotate my pin so that it connects properly. I don't know how to do that yet. I just want to get this mostly how I want it to be and fix it later. Go to there and then go up to here and then go over to here. All right. I think that'll work. I think the problem is I don't have the nets, that they're not identified as being on the same net. So like the net list for this is wrong. Save. I wonder if it's because it's marked S instead of 1, 2, 3, and 4. If maybe I would fix it by hold on. Alternate pin assignments? Oh, there we go. Alternate assignment. Maybe here's where I would type in like tip was 4, no, ring was, sheath was, I can't remember now. 1. I can't type there. I can't type in there. Oh, I would have to edit the symbol, right? I mean, I can do that. It's just gonna be separate from what's in the library. The other, yeah, I might have to just make my own symbol derived from this one because I'm gonna want to mark it that it's a power input, right? Okay, I'll figure this stuff out later. I need to do some research on this anyway, and I've been going for 4 hours, so I'm going to not edit that. I will save that. I'll go to here. What happens if I do update from schematic? Is it going to blow away stuff? Okay, errors. Okay, yeah, it's the pads aren't matching the connector. That's probably why the nets don't work. Okay. Well, I can fix that. I can try fixing that really quick, right? I can save. Go to the footprint editor. And I can just have those pads match exactly, right? So project, this one. So we'll just call this one, what was one again? One is S. Two is ring 2, I think. No, yeah, ring 2? If I get this wrong, I get it wrong. I'll fix it later. So this would be ring 3, ring 1. And these are both tip. I think. Yes. Yep. Now, did I actually make the symbol backwards? That would be really embarrassing if I did. No, the tip is... Why is the tip connector all like that right there? Huh. Interesting. It is. It doesn't seem like it should be. Okay, so save that. Back to the schematic. And I think I do update symbol from library. No, I do this one, right? I'll just reselect it. Okay, and then save it. Now pull it in from the schematic. It is there, so I did add those pads, so why is it giving me problems? Let me try deleting the symbol and updating schematic again. Okay, yeah, I don't know how to update, but it looks like the rest nest is correct now. So I should have better luck with these traces, right? Let's delete them and reroute them. Okay, and then move this guy to right here. Okay, so this looks better, right? So this should give me an easier time routing this. Go from there to, yeah, see, it's helping me. And then it's not fighting me anymore. Which one is which? This, oh, it's even highlighting it for me. It's like, move it up to there. How do I get it up to there? Oh, I gotta cross out of the trace. Okay, so we'll just hang close to here and then go in there. Ah, much better. Okay. Why is it sneaking around that way? Let's sneak around this other way, please. Oh, because it's smart. It knows I have to do that. Okay, so then we'll cancel that guy. Let me do that one first then. Okay, so go from here up to there. Go from here. Oh, it's going around though. Shoot. So I should do the other one first, but leave room for the other guy. X is the shortcut. This one first? But then leave room for the... No. This one first. But leave some room for the other guy to get through. Whoa. Okay, and now do this one, and it should... Oh, I did it wrong again. Dang it. Oh, I think I know what I can do. I can just do one on the front. There. We'll do one on the front side. Actually, maybe all of them on the front. Just go around to that. And then this one can go on the back, right? Connect that to there. And there to... we can't make it through there? There, it made it through. I had to finagle it through. There. Alright. Can you run those traces on the top layer? Seems like there's more room. Yeah, I did. I ran them on the top layer. I didn't want to run the... what is that one? The ground. Right? I didn't want the ground to run on the top because I would run into these other signals. I guess it doesn't really make a difference. I have ground on the back, power on the top. Bottom and top, right? So, or forward and front and back. I have the ground on the back, power, and signals on the front. Anyway, let me run the check thing. Hey, no warnings or errors. Cool, so I've updated my symbol to the jack that I think that I bought. I just have to wait until I get it and make sure that these dimensions are good. No, it didn't give me any errors about the silk screen because I actually didn't have the silk screen running over the copper. Okay, so that must be like a keep out? That ring around it? Because that's not actually a copper line. The copper is the thick part, right? If you haven't been able to figure it out, I'm really, really new to this stuff. Okay, but I'm done for now. This stuff is challenging for me, and it saps me of my energy. And I really do want to... I need to go back and redo this to get rid of these wires and instead use net names. That's probably why it doesn't show up with a nice name on the PCB either. But I'll do that later. Close this guy. Let me just make sure this is all checked in. Okay, so here's what we changed. Is this a cache? It's info cache. Right, so we're pulling in another... my footprint library. It's interesting how all the files are in text. Git commit. This is PCB work. Mostly with... actually, it was all with the TRS connector, right? So what did I do here? Add project level footprint library. Add footprint for this specific part. I already closed it. I like copy paste. Let's do copy paste. Can select it. Ah, come on. All right. So this is a connector for C audio jack. use the new footprint for the TRS connector on the PCB. Schematic. And then reroute nets between TRS connector and controller socket. Cool. I think I'm gonna end the stream now. Let's see if I have a friend who is streaming I can raid. Oh, Chris is still going. Oh, wait. Tim raided me yesterday, so I'll raid Tim back. That's what I'll do. How's the project going? Pretty good. I'll talk for a little bit before I hit this button here. Make sure I get Tim's name right. Okay, so the project's going pretty well. Today I did a bunch of refactoring of the firmware, and I did a little bit of update to the PCB, making the TRS connector footprint match the one I ordered earlier today. So the refactoring took a bit of time. I fixed a bunch of bugs. No major updates, but I have these two controllers able to program each other. I forgot to mention I resoldered the socket, this Kyle socket, to the pins that I'm using for the breadboard, so it's working again. I have two keys I can press again, W and Q. So I'm not sure what I'm gonna do next stream, but I have parts on the way. Probably I need to push towards making the next level prototype with the PCB and prove that stuff out. So yeah, when would I stream next? Maybe tomorrow? I'm not sure. But anyway, thanks for watching. We're gonna go watch Tim Bodette now. He's working on his own games for his own company. So hope to see you next time. Take care. Bye.